Hi, now we are going to talk about the new chapter, electricity. Very interesting topic. And the insulation எடுத்துட்டு you can see that copper wire. அப்ப அதை தொட்ட உடனே ஷாக் அடிக்குமா அது? ஏன்னா நம்ம தான் காப்பர் வயர்ல ஃப்ரீ எலக்ட்ரான்ஸ் ஆர் மூவிங்னு சொல்றோமே. அப்ப will you get a shock when you touch the wire? You can try, but please inform your house people what you are doing. நீ பாட்டுக்கு பேப்பரை கிழிச்சு தூக்கி போட்டேன்னா பாக்குறவங்க எல்லாம் தப்பா நினைப்பாங்க. Normally we call this point as infinity. Sir, infinity means கண்ணு கெட்டாத தூரம். It is not like that. Sir, why you are getting different size, but the voltage is 1.5 volts. Okay. Now you take a wire from this point to this point, you connect a wire, switch on mean the wire will get fire. 99% persons use the terminology, sir, enga veetla current illa. Almost 100%. Virtually that is true, but physics wise you should not use like that. This 0.1 volt has gone for the internal resistance. Now if we measure using the voltmeter, it is showing only 1.4. That is called the potential difference. Basics of electricity we are going to talk here. In detail, in part 2 we will do. Electricity means first what is coming to your mind is current. What is current? How current is flowing? First of all, the question of current flowing is wrong. It is the electrons which flow. Current is not flowing, electrons only flowing. So electric charges, whenever you take a copper wire, it has got so many free electrons. All the electrons possess some velocity. When you buy a wire from a shop for household circuitry, இப்ப நீ போய் கடையில ஒரு ஒயர் வாங்குறீங்க, இந்த ஒயர் குவாலிட்டி வந்து நல்ல குவாலிட்டியான்னு வாங்கணும், நமக்கு தெரியாது. ஸோ இந்த ஒயர் வாங்கும்போது அதோட எண்டு, அந்த பிரிசில்ஸ்னு பேர் அதுக்கு, இந்த எண்டை வந்து நம்ம எலக்ட்ரிஷியனுக்கு தெரியும் இது நல்ல குவாலிட்டி அப்படின்னு சொல்லிட்டு. ஸோ நம்ம என்ன பண்ணுவோம்னா, அந்த இதே எண்டு வந்து ஏதோ ஒரு வாங்கிட்டு நாங்கள் 10 மீட்டர் 10 மீட்டர் நம்ம வேணும். அப்ப அந்த எண்டு வந்து ஷார்ப் பண்ணி வச்சிருப்பாங்க. அந்த இன்சுலேஷன் எடுத்துட்டு யூ கேன் see that காப்பர் ஒயர். அப்ப அதை தொட்ட உடனே ஷாக் அடிக்குமா அது? ஏன்னா நம்ம தான் காப்பர் ஒயர்ல ஃப்ரீ எலக்ட்ரான்ஸ் ஆர் மூவிங்னு சொல்றோமே. அப்ப will you get a shock when you touch the wire? No. அப்ப same wire is connected here in your household circuitry. If you touch that bare end, you are getting a shock. Why, sir? This is subjected to external electric field. கடையில ஒயர் வாங்கும்போது அந்த இடத்துல எலக்ட்ரிக் ஃபீல்டு கிடையாது. சும்மா நார்மல் ஒயரை வைண்ட் பண்ணி வச்சிருக்காங்க. அதை நீ பார்த்துட்டு 10 மீட்டர் 20 மீட்டர் 50 மீட்டர் வாங்கிட்டு வரீங்க. தட்ஸ் ஆல். There also we have electrons, but they are moving in random direction. Velocity of electron is not zero. Net velocity is zero. Electrons moving in different directions. So velocity, direction of one particular side, another particular side cancels. It is not that electrons are at rest. Electrons moving. Electrons are moving there with a velocity of nearly 10 power 6 meter per second. Second part we will do that. So this is flow of electrons. When it is subjected to external electric field, it comes to the current. Fine. Generally, electrons means what is the meaning? There is a charge transformation. Initially, scientists gave a small idea how electrons are produced. Later on, using discharge of electricity through gases, we are getting the electrons through cathode rays. When one body is rubbing over the other, you take a glass rod, rub with silk material. You take a comb, just comb your hair. You cannot call this as rubbing, but one body rubbing over the other. To some extent, we can accept. What is the meaning here? When you comb your hair, comb is losing the negative charge, that is electrons. When electrons are lost, means it becomes positive. Generally, if you take an atom, nucleus is inside, protons and neutrons are inside the nucleus, electrons are revolving. Electrons value and protons value are equal, electrically neutral. This already you would have learned. So now there is no question of protons here. It is called ions. When you remove an electron, so when you comb your hair, what is happening here? Electrons are lost. So comb becomes positive charge, positively charged. Hair gains electrons. That is a momentary one. So after some time, after combing your hair, you take a bits of paper and put it on the comb. It will attract. Momentary charges. When you switch on the TV, keep your hand closer to the screen. You can feel something on your hand. Stationary charges. You can take bits of paper. When you just put it on the screen, one or two might stick on. So this is called static electricity. You can try, but please inform your house people what you are doing. நீ பாட்டுக்கு பேப்பரை கிழிச்சு கிழிச்சு தூக்கி போட்டேன்னா பாக்குறவங்களாம் தப்பா நினைப்பாங்க. I am just experimenting, so let us say that. Okay. அப்போ the total charge Q is Ne, where N is called the number of charges, E is called the charge of an electron. E is equal to 1.6 10 power minus 19 coulomb. Charge of an electron value. So through this electron transformation only, we can talk about current. For that, we should know what is called the potential difference. Then only current comes. So basic concept, transformation of charges. Transformation of charges means when one body rubbing over the other. That is called transformation. Fine. Sir, electric field. What is called electric field? You can talk about gravitational field. You might have heard about gravitational field. Magnetic field. Like that, electric field. Whenever you throw an object in the upward direction, after some time it is coming down because a gravitational force. It is influenced by a gravitational force. You take a bar magnet, keep a small iron piece, bring it closer by. After making very close distance, it is getting attracted. So this is called magnetic field region. Similarly, electric field means force experienced by a charge. I don't understand, sir. Force experience per unit charge. Why you should experience a force, sir? Example. Suppose I have a charge plus Q. This plus Q has got some electric field lines. Region. It is a region around which electric influence can be felt. That only we are going to discuss. So you are taking another charge here, say plus 1 coulomb. You are moving +1 coulomb from this point to this point. The force experienced by this charge +1 coulomb at this point, we call it as electric field. Sometimes we can call this one as point charge also. Magnitude is less. That's all. Here 1 coulomb of charge, Q0 test charge. You can take that one. Q0 charge you are moving. Normally we call this point as infinity. Sir, infinity means kannu kettada dooram. It is not like that. It depends. If you take a magnet closer to the magnet, you are bringing the iron piece at one particular point only. We are feeling the iron piece is getting attracted. When you keep the iron piece closer to the magnet, at one particular point it is getting attracted. So beyond this, any point you take, it is called infinity for this magnet. Similarly, this is a region of electric field. Any point outside the region, we call it as infinity. Middle of the road, you are standing and you are seeing a person who is moving on the other side. You can see the person. After some distance, the person appears to be very small. After that, a point, then he disappears. That particular point is called persistent of vision of the eye. Up to that, you can see. Beyond that point, any point, you call it as infinity. That's all. So infinity word differs from every point, every stage, every field. Gravitational field, magnetic field, electric field. Okay. So this is called electric field region. Fine. Electric potential. Sir, I have a charge plus Q. Here I want to calculate the electric potential. You are moving +1 coulomb charge from infinity to this point. Work done in moving a unit positive charge from infinity to the particular point, we call it as electric potential at this point. Definitely against the repulsive force. Against the force only it will act. Why against? This is plus Q. You are moving +1 coulomb. So you can say like charges repel. Two positive charges or two negative charges, when they brought together, it is repelling. 1 plus 1 minus attraction. One positive charge, one negative charge, attraction. So when you move this +1 coulomb within the electric field region, what is the work done by that particular charge? When you move, you call it as electric potential. Sir, potential difference I want, sir. When you talk about potential difference, same concept, plus Q. This is electric field. These 2 points, we call it as A and B. You forget about this example. Come back. Work done in moving a positive charge from infinity to A, infinity to B. W1, W2. 100 joules minus 80 joules, 20 joules. The 20 joule is the work done in moving a charge from infinity to one point to infinity to another point, the difference. So this is called electric potential difference. Sir, why we have to do like this, sir? Simply you can do, take that +1 coulomb, keep it at point B, move it to point A. That's all. Between 2 points only you want to calculate potential difference, ma. From one point to the other point you move. What is the work done? You calculate. That is called potential difference. How will you get 20, sir? 20 minus 0. That's all. 100 minus 80 is also 20. 20 minus 0 is also 20. 20 joules. So potential difference means you need 2 points. By providing potential difference only, the word current is entering into the concept. You take a battery, say 1.5 volts battery. You have got positive charge, you have got negative charge, negative side, positive side, negative side. Normally, you can take that ever-ready battery. Ever-ready battery I am using. That projected end we call it as positive, other end we call it as negative. TV remote and all we are using. You can see here. Nippo battery. Okay, Nippo battery. Anything you can use. Nippo battery. This projected end, we call it as positive. This end, we call it as negative. This is 1.5 volts. Similarly, we can use every. This is called, the thickness is short, very small. For clock and all, we'll use a big size battery. Torch, we'll use a very big size battery, all 1.5 volts only. Sir, why you are getting different size, but the voltage is 1.5 volts? Why it is? Second part we will discuss. We have to talk something about internal resistance. Whether it is a dry cell or a normal cell, we should talk about something called internal resistance. It is because of the internal resistance of that cell or battery, you are getting this value. Same 1.5 volts. The internal resistance of that big size battery is more. This size internal resistance is less. That's all. Second part, we will discuss all these things. So, whenever you provide potential difference, one side positive, one side negative, it is connected by a wire. Directly positive to negative, if you connect by a wire, it is called a short. You are short circuiting. What is the meaning of short circuit? Don't try. An example I am telling. Don't try. Household circuitry, you have got 3 pins. Take one wire. You find out using a tester which is live neutral. This is called earth. Third pin, we call it as earth pin. Two holes we have. Using a tester, you find out one is called live, another is called neutral. This is positive, this is negative, sir. No. This is called alternating current. What we are using in our household circuitry is AC, alternating current. There is no question of positive, negative here. Two holes means one is called live, another is called neutral. When you put a tester inside this hole, light will glow. Here, light will not glow. That's all. Second part we will discuss in detail. AC, DC, difference, what is called single phase connection, 3-phase connection, all these things. Okay. Now, you take a wire from this point to this point, you connect a wire, switch on mean the wire will get fire. After some time, you can see fire. That's all over. Short circuit, fuse. You should not do that. So directly positive to negative, we cannot use. I want to connect this 1.5 volts for a serial small bulb. I want to make it glow, sir. You can connect it to a bulb positive, bulb negative to this one. The serial bulb will glow. So through an electric appliance only we can use. Not directly want to positive and negative. Sir, I want to make the electrons to flow. You make the electrons to flow for what purpose, sir? For making this wire coming into fire? No. For utility only we need. Okay. Now, electric current. I have a wire having so many free electrons in the wire connected to positive and negative of the external supply. This is not your AC household circuitry. Positive and negative means that is called DC, direct current, plus minus. You know very well electrons, or this is electron. Electrons are attracted towards positive because charge of an electron is negative. So these electrons are attracted towards a positive. Direction of current means it is direction of positive charges. Sir, you only told electron movement only current. Then where is the question of positive charges? I told direction of current is direction of movement of positive charges. Not that positive charges are moving. Electrons are moving one direction, no, opposite to that current. That's all. Because electron charge is negative in one direction, current moving in opposite. I is equal to how many charge, how much amount of charge flowing for a given time t. Coulombs per second. Unit of electric charge is coulomb. Time is t. So coulomb per second, we call it as ampere. So ampere is a unit of current. Correct? So we have seen what is called potential, what is called potential difference. Then using that current, whenever you're using the term, sir, எங்க வீட்டுல current போயிடுது சார். 99% persons use the terminology, sir, எங்க வீட்டுல current இல்லை. Almost 100%. Virtually that is true, but physics wise you should not use like that. Sir, எங்க வீட்டுல பவர் இல்லை சார். அப்படிதான் நீ சொல்லணும். கரண்ட் எப்போ வரும் அப்படின்னா, you provide a potential, you connect it to the circuit, you allow the electrons to flow, then only current word will come. நீ பவரே கொடுக்காம கரண்ட் இல்லைன்னா என்ன பண்ண முடியும்? பவர் இல்லைன்னு சொல்ல அது கரெக்ட். டெர்மினாலஜி அவ்வளவுதான். வாட் இஸ் யுவர் வெயிட், வாட் இஸ் யுவர் மாஸ், நம்ம 11th ஸ்டாண்டர்ட்ல படிச்சோம் இல்லையா, இங்க அதே மாதிரி வாட் இஸ் யுவர் வெயிட் தான் பேசுவோம், பட் ஆக்சுவலி இட் இஸ் யுவர் மாஸ். Okay, so I is equal to Q by T is the basic information regarding electric current. Okay, fine. Next, EMF. Electromotive force. அப்படின்னா என்ன சார்? ஃபோர்ஸா சார் அது? No, it is not a force. இப்போ you have a tube, ஒரு வாட்டர் டியூப் இருக்கு, இது ஃபுல்லா வாட்டர் இருக்கு, ரெண்டு பக்கம் நீ இப்படியே பிடிச்சுட்டு இருக்க, ஃபுல்லா தண்ணி இருக்கு உள்ளுக்குள்ள. நீ இப்படி பிடிச்சுன்னா தண்ணி அப்படியே தான் இருக்கும், ஒண்ணுமே ஆகாது. You just change the height. When you change the height, here from the ground this point is more height, from the ground this point is lesser height. Appo potential energy at this point is more, potential energy at this point is less. So you are giving potential difference, potential energy difference. Appo the water will flow. Final potential energy minus initial potential energy. Appo water is flowing. The same thing. You provide a potential difference, then only electrons will flow. By chemical action, one particular side is making positive, other side is negative. Second part of electricity, we will talk about Leclanche cell, Daniel cell, dry cell, that and all. It is called primary cells. Secondary cells mean that is called battery, what you are using, lithium battery, normal battery. You have got rechargeable battery also. So we are not going to talk in the second part, rechargeable battery and all, normal battery. In the case of primary cells, one time if it is prepared solution, Leclanche cell solution type, prepared a solution, it is giving 1.5 volts. After some hours, after some days, the potential is going on reducing. It has got some internal resistance. We will talk about that later. Now, freshly prepared cell, plus minus, you connected to a voltmeter. Voltmeter is showing 1.5 volts. So work done in moving or in driving, that is called driving force. Work done for the charge to move, for the charge to drive to the other side. We call it as EMF, electromotive force. It is motivating. It is driving force. It is called a driving force, electromotive force. No external appliances connected here. You are directly measuring the voltage using the voltmeter. Voltmeter will show 1.5 volts. Sir, same thing you tell potential. Potential difference, it is different. I told you already. Potential difference means you have a battery or cell prepared, connected to a key, connected to a circuit. The circuit has got some external resistance. Ammeter, voltmeter, whatever you want to connect, no problem. This is sometimes you can connect it to a bulb also. Sometimes external resistance or anything. So this is called potential difference. Current is flowing to the external circuit. EMF represented by psi. Potential difference or voltage is expressed by V. Psi is equal to V. Can we use this term, sir? Only one particular time we can use this term. Psi is equal to V. When internal resistance of that particular cell is 0. But normally it is not like that. We have got some internal resistance. No cell has got 100% efficiency, sir. We have got some internal resistance. So you cannot say that internal resistance is 0. If that is 0, then you can say psi is equal to V. Otherwise, psi is equal to V plus some current is always current flows from positive to negative, I. R is called internal resistance of the cell, or V is equal to psi minus IR. Sir, you please explain with an example. We can explain. You are preparing a cell of 1.5 volts. EMF is 1.5 volts. What is the potential difference, sir? That potential difference V is 1.4 is equal to 1.5 minus 0.1. This 0.1 volt has gone for the internal resistance. Now, if we measure using the voltmeter, it is showing only 1.4. That is called the potential difference. Freshly prepared cell you measure. Actually, the value is 1.5 when it is subjected to external circuit. External current when it is flowing for an appliance, any electric appliance you take. We can call that one as potential difference. Always it is less than the EMF. Potential difference can be equal to EMF if internal resistance is 0. Otherwise, always it is less only. It cannot be more. Sir, whenever we talk, here also the formula, potential or voltage, V is equal to same formula, W by Q. Psi is also equal to W by Q. Work done per unit charge. Formula wise same. That is joules per coulomb or volt. Joules per coulomb or volt. Both are same. Unit wise. Now, we have got some effects for the current which is flowing. What is the meaning of effects, sir? Again, this topic we'll discuss later, but actually I can tell you the effect. Heating effect of current. Chemical effect of current. Magnetic effect of current. Detail we will discuss later. Just I'll give you a small introduction. Heating effect of current. Suppose current is passing through a wire. The heat energy. This is nothing but energy. Is given by the formula I square RT. What is this I square RT and all? I will explain. In chemical effects of current. Suppose you take a solution, keep two rods. One is called a carbon rod, another is called a copper thick wire. You connect it externally to 1.5 volts battery. Moment you connect, Copper ions will be deposited on the carbon rod. Copper Cu++ ions are deposited. So copper is positive. That is called anode. Carbon rod, what we are using there is cathode. The solution, what we are using, that is called electrolyte. The phenomenon, we call it as electrolysis. Of course, only hello or introduction only are given. In detail about electrolysis, we will discuss in the second part. Magnetic effects of current, very interesting topic. Huge topic. Whenever current is flowing through the circuit, there exists a magnetic field in the surrounding. That is called magnetic effects of current. Oersted only formulated the idea. We will discuss later what is called magnetic effect.